Hi boys and girls, today we're going to be doing Unit 10 review. So we're going to go over exponential growth, exponential decay, and we're going to compare linear and exponential functions. So starting with number 1, it says state whether each of the following scenarios represents an exponential or a linear function. So these are our two words that we're going to be putting in the blank, whether it's exponential or linear. So before we even start this, I just want to review a little bit. Exponential means that we're going to be multiplying. And linear means that we're going to be either adding or subtracting. So I want you to keep that in mind when we're going through each of these questions. So A, a population of bacteria that doubles every hour. So doubles is a key word, so I'm just going to box that. When I'm doubling something, so let's say I started out with 100, and I double it, that means I'm going to be going to 200. If I double 200, I'm going to 400. If I double 400, I'm going to 800. So what's happening each time from 100 to 200 is I'm multiplying by 2. To get from 200 to 400, I'm multiplying by 2. To get to 400 to 800, I'm multiplying by 2. So doubles, if I'm doubling something, that means I'm multiplying by 2. So because I'm multiplying, that means it's exponential. B, a topical antibiotic that is applied 2 times each day. So I'm going to circle 2, and I'm going to put times each day. I'm going to underline that. So if I drew myself a little graph, and my days were at the bottom, I had day 1, I applied 2 times. Day 2, I applied 2 times. Day 3, I applied 3 times. So if I'm looking at my graph here, if I'm looking at my graph here, it's just a straight line. I'm applying 2 times each day. So that would be a linear function. Part C, an airplane that travels at a constant speed of 550 miles per hour. That keyword constant means that I'm just staying at 550 miles per hour consistently. Constantly. No matter what, the airplane is staying at a speed of 550 miles per hour. So because it's staying the whole time at 550 miles per hour, it's going in a straight line. So again, that one is linear. D, a tournament in which half of the players are eliminated after each round. So I'm going to box half. That's like my number that I'm talking about. And I'm going to box eliminated. So right on the left side, I'm just going to write like a little scenario. Let's say we started out with 8 players. And now after the first round, half of them were eliminated. So then it became 4 players. Then it was eliminated by half again. So then it became 2 players. So what's happening when I go from 8 to 4 is really I'm splitting it in half, which means I'm multiplying by a half. So if I take 8 and multiply by half, I'm going to get 4. If I multiply by half again, I'm going to get 2. So because I'm multiplying by a half, that means it is exponential because I'm multiplying. E, a bank account that earns interest at a rate of 3.4% each year. So earns interest is a keyword at a rate of 3.4%. So anytime I'm talking about earning interest, I'm thinking about increasing. So I'm increasing at a percent rate of 3.4%. So if I'm increasing at a percent, I want to think exponential. Anytime you see that percent and an increase, you're going to think exponential. A radioactive substance that decays, that's a keyword that we've learned in previous lessons, by a factor of 1/2 every 29 days. So decays, when we talked about decay, we talked about exponential decay and exponential growth. So decay means that I'm going down or I'm decreasing by a factor of 1/2, which means that I'm going to be almost like splitting it in half again, like we did before. So because I'm decaying at a factor of 1/2, that means I'm going to be multiplying by a half. That is exponential. if we wanted to know if it was exponential decay or growth, well, it says decays, so it would be exponential decay. G, the total cost of a club membership that charges a flat fee plus $15 a month. So, let's say I started off with a flat fee. It's like my first fee, my initial fee. I started off with $40. And now it's saying that I'm a flat fee plus $15 a month. So plus $15 for the first month, plus $15 for the second month, plus $15 for the third month, and so on and so on. So because I would just be adding 15 each month, that means it's linear. Because I would be adding. That keyword plus tells me that I'm adding. A child that puts $5 into a piggy bank every Sunday. So a child is putting $5 into the piggy bank every Sunday. So let's say week 1, I put 5 in. Week 2, I put another 5 in, so now I'm up to 10. Oops, week 2. Week 3, I put another 5 in, so now I'm up to 15. So each week, I am increasing by 5 by adding 5 each time. So because I'm adding 5, it's going to be linear. Remember, adding or subtracting is linear, multiplying is exponential. I, a bucket that is filling with water at a rate of 1 centimeter per day. So a bucket is filling with water at a rate of 1 centimeter per day. So each day, it's just increasing by 1 centimeter. So because I'm increasing by 1 centimeter each day, that means I'm going to be adding 1 centimeter. So because I'm adding, it's going to be linear. J, an eraser that decreases in size by 1.2% after each day. So I see decreases, which means I'm going to be going down, and I see a percent. So if I'm decreasing by a percent, that means it's going to be exponential. A teacher that deducts 5 points from a project each day it is late. So deducts means that I'm subtracting, right? Or I'm decreasing 5 points from a project each day it is late. So let's say day 1 you start out with 100. Day 2, we deduct 5 points, that's a 95. Day 3 becomes a 90. So each day it's getting later and later, it's decreasing by 5, which means I'm subtracting 5 points off, or I'm taking away 5 points. So because I'm subtracting, it is going to be linear. A runner that is increasing the number of miles ran by 2 miles each week. So, I'm going to write it down here. So let's say week 1, start off by doing 3 miles. Week 2, now it says increasing the number of miles by 2 each week. So that second week, it's now increasing by 2 miles. So not 3 miles, but it's going to become 5 miles. Week 3, I got to get 2 more miles on there, so not 5, but now I'm going to add 2 more to that to get 7 miles. So from 3 to 5, what I did was I added 2. From 5 to 7, I added 2. So because I'm adding 2 each week, it is linear. And the last one, a candle that burns at a rate of 0.01 millimeters per minute. So it burns at a rate of 0.01 millimeters per minute. So let's say the first minute, 0.01, second minute, 0.02. So each time, it is increasing by 0.01. So that one is also going to be linear because I'm adding. All right, looking at number 2. Amy purchased her first new car for $21,000. So that's what it started out as. So I'm going to put starting there. little note, and plans to sell the car after 10 years. The car depreciates, that's definitely a keyword, in value by 2.7% each year. Which expression could be used to determine how much money the car is worth after 10 years? So I'm going to underline my question. Oops, and I'm going to circle 10 years. All right, so it's multiple choice. So let's just look at our choices first. I noticed that 21,000 is on every single choice. I also know that there's a 1 on each choice, and then the exponent is 10 on each choice. The only differences between these choices are some have pluses over here and some have minuses right here. And then also these numbers right here are all a little bit different. So let's just focus on the pluses and the minuses to start. So I see a huge keyword right here that means that says depreciates, and that means that it's decreasing. Okay, we learned in our previous lessons that depreciate goes with decay. So because I'm decreasing or decaying, I know that it's going to be a subtraction sign. So what I'm going to do is I'm going to get rid of 1 and 2 because they have plus signs. I want the minus signs. Now I have a 50-50 shot. I have 2.7 or I have 0.027. Well, those numbers are coming straight from this 2.7%. And that 2.7% is our rate, or our R. So in the previous lessons, what we did is we didn't keep that 2.7 as a percent. What we had to do was change it to a decimal before we plugged into our formula. So in order to get that percent to a decimal, I need to divide by 100. When I divide by 100, it comes out to 0.027 in the calculator. And if I look at my two choices, well, choice 4 is the only one that has 0.027 in it. All right, next page. Okay, number 3. State whether each of the following tables represents a linear or exponential function. So you guys did do this in lesson 5. So we're going to look at each table. When we're looking at the tables, what we're going to focus on is the y values. Okay, so we're going to really focus on these columns, on all of them. Now our two choices are linear or exponential. Well, we just went over on the first page, linear means that I'm adding or subtracting. And exponential means that I'm multiplying. All right, so I'm going to talk quickly about the x values, but they're really very similar in all 4 of these problems. The x values, we do want to make sure that they increase by the same amount. So -1 to 0, I am adding 1. From 0 to 1, I am adding 1. From 1 to 2, I'm adding 1. 2 to 3, I'm adding 1. If you look at every other x column, it's very, very similar pattern. So I really want to focus on the y's when I'm deciding exponential or linear. So let's take a look. The first part is a fraction, so to get to half to a 1 might be a little bit tricky because I know we don't like fractions that much. So let's just look at from 1 to 2, and from 2 to 4, and from 4 to 8. We're going to look at that pattern. Well, to get from 1 to 2, there's kind of 2 options, right? Maybe I can add 1 and get to 2, but then I need to make sure that it's a consistent pattern. If I add 1 to 2, that gives me 3, and this says 4. So I'm not going to add, but let's try multiplication. Well, if I multiply, to get from 1 to 2, I need to multiply by 2, right? 1 times 2 is 2. Well, now 2 times 2 is 4. Okay, that's good so far. And then 4 times 2 is 8. Now I just really need to make sure that one other piece that I left hanging in that fraction works as well. So 1/2 times 2, if you type that in the calculator, you do end up getting 1. So because I'm consistently multiplying by 2 on every single piece, that means it's going to be exponential. And it's exponential because we multiplied. I'm just going to put multiplication down there as a little note for ourselves. We multiplied by 2, or we doubled each time. All right, looking at the second one. From 3 to a -1, if you try that in the calculator, to get from a -3 to a -1, I need to add 2. To get from a -1 to a 1, I need to add 2. To get to a 1 to a 3, add 2. 3 to 5, add 2. Okay, so I'm consistently adding by 2. So adds by 2 or increases by 2. Because I'm adding, that key word right there means that it's going to be a linear. We multiplied over here, it was exponential. We added, it's going to be linear. So taking a look at the third one. Uh-oh, I see some fractions again. So I'm going to actually skip the fractions for now. I'm going to go with the numbers that I know that are a little bit easier. So let's start from 1 to 3. Well, I know I can multiply 1 times 3 to get to 3. Well, let's check the other ones. 3 times 3, so I'm using that same number, does get me to 9. And then 9 times 3 does get me to 27. All right, we're good so far. Let's double check the fractions. 1/3 times 3 does get me to 1. 1/9 times 3 does get me to 1/3. So I'm multiplying by 3 each time. It works. So multiplied by 3 each time, or I tripled. Because I multiplied, it was exponential. Oops. Looking at the fourth one. 12 to 19. Well, if I think about that for a sec, I don't think any number times 12 is going to get me to 19. So let's try some addition. 12 plus 7 is going to get me to 19. 19, now I'm going to check. Well, does 19 plus 7 get me to 26? Yes, it does. And then 26 plus 7, does it get me to 33? Yes, it does. So I added by 7 each time. Because I added, it's going to be linear. All right, question 4. A little bit of multiple choice for us. The equation P equals 850 parentheses 1.04 raised to the t. So that looks like our formulas that we've been using, our exponential formulas. So that is being used to calculate the value of a painting. They want to know, what does 1.04 represent in this equation? So if we look at our choices, we have a bunch of percents, and then we have growth, decay, growth, decay. So let's first try to just figure out if it's growth or decay. In order to do that, what we're going to do is we're going to look at this 1.4 inside the parentheses. If that number is bigger than 1, it's going to be growth. If it is less than 1, it is going to be decay. So this 1.04 is bigger than 1, so I know it's going to be growth. So let's get rid of some choices. Well, if I know it's going to be growth, let's get rid of the decay. Get rid of choice 2. Get rid of choice 4. All right, well, is it going to be 4% or is it going to be 0.04%? So now we got to really think about our formula. We started out with P equals 850 parentheses 1.04 raised to the t. That's what we started out with. Now we just decided it was growth, right? So I'm going to write my growth formula. It was y equals a parentheses 1 plus, because it was growth, r raised to the t. Now this 1.04 and this 1 plus r are the two pieces that kind of like match each other, right? So what I can do, like we did in previous problems, or previous lessons, I should say, is we set them equal to each other to figure out what the r was. Because that's what they're talking about here. When they give us these percents, they're talking about what the rate is. So 1 plus r equals 1.04. And now I'm just going to solve. Well, I'm going to minus 1, minus 1. The r, when I subtract those two numbers out, it becomes 0.04. Now that rate is 0.04 as a decimal. If you look at our choices, they both write it in percent form. Well, this is a decimal and this is percent. So I have to be careful. Those don't match because this doesn't have a percent. So it can't be choice 3. It must be choice 1. I'm going to show you how we got to that 4% growth. So So this 0.04, to get it to a percent, I need to multiply by 100. 0.04 times 100 does get me to 4, and that's how I change it to a percent. Question number 5. Holly invested $2,500 in an account with 1.7% annual interest rate. She made no deposits or withdrawals on the account for 6 years. That just means that nothing happened. Okay, so back in the first sentence, I circled my key numbers. I'm also going to box annual, that just means every year, and interest rate. When I see interest rate, I want to think of that I'm increasing. If the interest, I'm going to keep reading right here. If interest was compounded annually, so every year, which equation represents the balance in the account after 6 years? So I'm going to just write on the side over here. We said interest means that I was increasing, right? So if I look at my choices, again, I have the 2,500 in all 4 choices. I have the 1 in all 4 choices, and I have this exponent of 6 in all 4 choices. So the only difference, again, is the plus signs. Some has plus, some has minus. And then these rates right here, all the decimals. Okay, so let's first decide if it's plus or minus. Well, interest, we wrote up here, means to increase, so that would mean it's growth. So that means it's going to be a plus sign. So let's get rid of the 2 minus signs. 2 choices with the minus signs. All right, so now I got to decide, well, is it going to be the rate going to be 0.017 or is it going to be 1.7? Well, it starts out in the problem as 1.7%. But I know that I'm not going to keep that as a percent. I need to change it to a decimal. In order to change it to a decimal, I need to divide by 100. We've done this before. When I divide by 100, I get 0.017. Well, that matches choice 1. So I circle choice 1. Again, I should always know that I'm going to do something to that percent. So it shouldn't match right away. Okay, I'm going to have to change it in some way. So by changing it, I divide by 100, and that's where I get that 0.017. Example 6. The value of an antique vase in dollars, T of X, after X years is represented by the equation T of X equals 1,800, parentheses 1.07, raised to the X. They want to know what is the initial value, it's a keyword, in the equation, and what does it represent. So let's just focus on what the initial value is. I'm going to rewrite it over here. T of X equals 1,800, parentheses 1.07, raised to the X. Okay, so my formula for exponentials, when that exponent up top is an X, my formula is y equals A, parentheses b to the X. So they want to know what is the initial value. So out of my formula here, this A, we should remember this from previous lessons, is always our initial value. Well, A and 1,800 are in the same exact spot. So right away, looking at my choices, I know the initial value is 1,800. So let's get rid of choice 3 and 4, because they don't have 1,800. Now I got to decide, well, what does that 1,800 represent? Does it represent the rate at which the vase increases in value? Or does it represent the original cost of the vase? Well, initial means the same thing as original or starting point or starting amount. So because initial and original mean the same exact thing, choice 2 is our correct answer. Just to clarify with choice number 1, it talks about the rate, and I know the rate is R. Well, the R should always be inside my parentheses, and that 1,800 is not inside the parentheses. Okay, next page. I know this is kind of a long one, guys, but just stay with us. It is a review, so there's a lot for us to cover. All right, question number 7. Romano invested $400. So invested $400 into an account at a 2.32% annual interest rate. There's those key words again. He made no deposits or withdrawals on the account for 5 years. So that means nothing happened within those 5 years. He didn't make any deposits, and he didn't withdraw any money. So the interest was compounded annually, which means every year. They want us to find to the nearest cent the balance of the account after 5 years. So whenever I see interest, I want to think of increasing. So it's increasing at 2.32%. So because it's increasing at a percent rate, that means it's going to be exponential. And because it's increasing, it's going to be exponential growth. So I'm going to write my exponential growth formula. Y equals A parentheses 1 plus R raised to the T. So those are my 3 pieces I need. I need my A, I need my R, I need my T. My A is the initial, which in this case it says that he invested $400. So that would be my initial or my starting. The R is the rate. That would be my percent. Well, the percent is 2.32%. I got to change it to a decimal. I got to divide by 100. I get 0.0232. And then my time, they want to know after 5 years. So I'm just going to plug those 3 pieces in. Well, Y equals my 400 parentheses 1 plus my R over here was 0.0232 raised to my T, which was 5, or my time that was 5 years. I just plug this all in the calculator. I get Y equals 448.603498. But they want me to round to the nearest cent. So when I'm talking about money, we know that change is 2 spots after the decimal. So I'm going to be focusing on this 0. I need to look at the next number, which is 3. Well, so that since that 3 is 4 or less, I'm going to give it a rest. I'm going to keep the 0. So $448.60 should be my final answer. Looking at number 8. Rachel and her friend Monica planted a sunflower in a garden. The height of the sunflower in inches is shown in the table below. We have a table here. Number of weeks, X. So these are my X values. And the height of the sunflower, H of X. Well, I know H of X is the same thing as Y values. It says, okay, so they give us our table. It says Rachel wants to use a linear function to model this information, and Monica wants to use an exponential function. So we have a linear function or we have an exponential function. Which model is the better choice? That's what we need to decide. And then explain why you chose this model. So earlier in the lesson, when we were looking at our tables, in order to decide if it was a linear function or an exponential function, we had to look at our Y values. So we had to look at these numbers right here. And we had to look at the pattern. All right, well, to get to 2 to 4, I know 2 choices. I'm either going to add or I'm going to multiply. Well, if I look at 2 to 4 and I times it by 2, right? So 2 times 2, I get 4. But now if I try to times 2 times the 4 here, I should be getting 8, but now I'm getting 6. So it can't be multiplication, so let's try addition. Well, if I take 2 to 4, and if I take 2 and I add 2, that gets me to 4. Now if I take 4 and I add 2, I get to 6. If I take 6 and I add 2, I get to 8. And I keep adding 2, I get to 10. Add 2, I get to 12. Add 2, I get to 14. Add 2, I get to 16. Add 2, I get to 18, right? So it's a consistent pattern. 2, 4, 6, 8, 10, 12, 14, 16, 18. Well, I'm adding by 2s, right? I'm counting by 2s. So I need to decide, well, was adding for linear or was adding exponential? So if we look back on our notes earlier in this lesson, I did write linear meant that I was adding or subtracting. And exponential mean I was multiplying. So in this case, the correct choice was Rachel. So it should be a linear function is the better choice. And now it says to explain. Well, because the y values, which is the height of the sunflower, increase by adding 2 each week. Okay, so it's a linear function because the y values increased by adding 2 each week. It was adding by a consistent number, that same number each time. Number 9. A used car was purchased in 2001. The equation used to determine the price of the car, C of x, after x years, is C of x equals 11,900, parentheses, 0.87 raised to the x. Explain what the 11,900 and the 0.87 represent in this equation. So I'm just going to rewrite it real quick. C of x equals 11,900, 0.87 raised to the x. Okay, they want to know what these two pieces mean. Well, I'm going to think back to my exponential formula. Because this x is an exponent up here, that's when I want to think of exponential. So my exponential formula is y equals a, parentheses, b to the x. Okay, well, the 11,900 is in place of the a. 11,900 is a. And if I look up here earlier, I wrote, well, a is the initial value. So a, which is the initial, in this case, the initial price of the car. And now I got to look at the 0.87. Well, the 0.87 is inside the parentheses, so that would be my b value. And back on the first lesson, we wrote the b value is what we multiply by. So in this case, we're multiplying by 0.87. If they ask us whether it was growth or decay, I would have to be focusing on that 0.87. Because that 0.87 is less than 1, it would mean that it was decay. I know they didn't ask us that, but we're going to add it at the bottom. So decay, because 0.87 is less than 1. That b value is less than 1. Okay, next page. Last question, but it does have 2 parts. Eric was given $150 for his 16th birthday. Eric wants to invest this money in a bank. Okay. Bank A will add $75 to his account each week. Bank B will double the amount in the account at the end of each week. Write a function in terms of x to model each option of savings. So I have 2 options going on here. I have Bank A, right? And I have Bank B. So let's write Bank A. And let's write Bank B down here. Okay. Well, when it says write a function in terms of x, I know that x has to be in there. And when it says write a function, I should have a y equals. So have a y equals. And now let's focus on Bank A's sentence. It says Bank A will add $75 to his account each week. Okay, but he started out with $150. Actually, both banks, Eric was given $150 to start, right? So both scenarios, he started with $150. So let's just write that for both of them. But Bank A added, okay, so I'm going to put a plus, $75 each week. I don't know how many weeks we're talking about. So if I don't know how many weeks we're talking about, that's where my x is going to come in. Up here, I know that each means I'm going to be multiplying, so I'm going to put a parentheses there to represent multiplication. And weeks I don't know, number of weeks I don't know, so that's going to be my x. So I start out with 150, and I add 75 each week. So I'm going to put 75 times x. Now let's look at Bank B and what they talk about. It says Bank B doubles the amount. Well, he started out with 150, and now Bank B is going to double. Well, I know double means that I'm going to multiply by 2. So 150 times 2. And then I still don't know how many weeks, so I'm going to raise that to an x because that is my exponential. Multiplying means exponential. So that had to be a, that had to be a y equals a, b to the x, because it says multiply. Bank A said to add, so that should have been linear. That's all they wanted for this part. They just wanted you to write the functions. You don't have to solve anything. They just want us to set up the functions. Now down here it says Eric wants to have at least $500 in his account after 1 month, which is 4 weeks. Determine which option will enable him to reach his goal. Justify your answer. So I'm just going to write myself a little note over here. At least 500 means that it needs to be 500 or more. So we're going to use both equations to figure out which one will be the correct one for him to use. Should he use Bank A or should he use Bank B? So let's rewrite our functions. Bank A was y equals 150 plus 75x. And then Bank B was y equals 150 times 2, because it was multiplying by 2, it's doubling, raised to the x power. Now the only thing I really can plug in for both of these is an x. So if I look back at my problem, x was the number of weeks. So in this part of this question, they do tell me 4 weeks, so that is my x value. So I'm going to rewrite this equation, but instead of x, I'm going to put 4. When I plug this into the calculator, it gives me $450. Let's do B. So again, y equals 150 times 2. The only thing I can plug in for is x. Well, we just decided that 4 is our x because it's 4 weeks. It's our time. If I type in 150 times 2 raised to the 4th, I get $2,400. So let's just go back to the question. It says determine which option will enable him to reach his goal. Well, his goal is at least $500. So which one is going to help him get to $500? Well, 450, does that get him to at least $500? Well, if at least means 500 or more, 450 is not 500 or more. So Bank B would be the correct one because 2,400 is definitely at least 500. It's a lot more, right? So over here, my final answer I have to answer it. I have to say Bank B enables him to reach his goal. And then I should say Bank B allows Eric $2,400, which is greater than $500. Okay, you could also add that Bank A doesn't work because $450 is less than $500 if you wanted to add a little extra in there. Okay, and justifying your answer, well, we showed all our work, so we're good there. But this should be really your final statement. All right, that is it for the review. So make sure you submit your work to us showing that you copied all the notes, and we'll see you on the next video.